table. So we're going to solve the inequality 3x squared minus 8x plus 4 over 2x squared minus 9x minus 5 is all greater than or equal to 0. So the first step is to put our rational inequality into factored form. So if we take our numerator, 3x squared minus 8x plus 4, and we want to factor it. So we need two numbers that add up to equal -8, and those same two numbers need to multiply to equal 3 times 4, which is 12. So those two numbers are going to be -6 and -2. -6 plus -2 is -8, and -6 times -2 is 12. So again, you can use whatever method you want to factor, but I'm going to show you the one that I always use. So I'm going to pull down my 3x, and I'm going to pull down my 3x. And then I'm going to have 3x subtract 6 and 3x subtract 2. And then my last step is just to divide both of those by the factor that divides evenly into both terms. So 3x and 6 would be 3, and between 3x and 2 would be 1. So 3x divided by 3 is just x, -6 divided by 3 is -2, and then I have 3x divided by 1 minus 2 divided by 1. So there it is in factored form. If I now do the denominator, I have 2x squared minus 9x minus 5. So I need two numbers that add up to equal -9, and those same two numbers need to multiply to equal 2 times -5, which is -10. So in this case, those two numbers are going to be -10 and 1. So again, I pull down the 2x, I have my -10. I pull down the 2x, I have my +1, and I divide by the biggest number that divides evenly into both. And when I do the division, I end up with x subtract 5 and 2x plus 1. So now I can write my inequality in its factored form. So in the numerator, I have x minus 2, and in times 3x minus 2, and in the denominator, I have x minus 5 times 2x plus 1. So if you remember when you were graphing, you can go from negative to positive at an x-intercept. You can also go from negative to positive at an asymptote. So we need to find both. So first we will find our x-intercepts. You get the x-intercepts by setting the numerator equal to 0. So I have x minus 2 times 3x minus 2 is all equal to 0. So therefore my x-intercepts are at x equals 2 and at x equals 2/3. To find my vertical asymptotes, I set my denominator equal to 0. So I have x minus 5 times 2x plus 1, and all of that is equal to 0. So then I know that my vertical asymptotes are going to be x equals 5, and from 2x plus 1, it's going to be x equals -1/2. So these are all the places we can switch from positive to negative. So just like when I was doing polynomial inequalities, I need to create myself a number line so I can come up with all the intervals. So I start down here at -infinity. My next smallest number between these four is going to be -1/2. This is a vertical asymptote. So I'm just going to draw it like it was an asymptote. Then my next smallest number is 2/3. That is an intercept. My next smallest number is 2. That is an intercept. And my next smallest number is 5, and that is an asymptote, and then positive infinity. So now I can draw my interval table. Remember, you put the factors down the side and the intervals across the top. So my factors are going to be x minus 2, 3x minus 2, x minus 5, and 2x plus 1. And then that function then is x minus 2 and 3x minus 2 all over. You can't even see all that. There we go. All over x minus 5 and 2x plus 1. So now for my intervals, so I just read them off. I'm going to go between negative infinity and negative 1/2. So negative infinity and negative 1/2. And then between negative 1/2 and 2/3. So negative 1/2 and 2/3. And then between 2/3 and 2. So 2/3 and 2. And then between 2 and 5. So 2 and 5. And then 5 and infinity. All right, so I've got all my intervals and all my factors, so now I just have to check out some test points. So between negative infinity and negative 1/2, I'll pick negative 10. So negative 10 minus 2 is negative 12. Negative 32, negative 15, and negative 19. Two negatives make a positive, two negatives make a positive, so I have a positive. Between negative 1/2 and 2/3, I can test 0. So 0 minus 2 is negative 2. Again, negative 2, negative 7, and positive 1. So I have two negatives make a positive, which is a negative, so I end up with a negative. Between 2/3 and 2, I can try 1. So 1 minus 2 is negative 1. 3 minus 2 is 1. 1 minus 5 is negative 4. And 2 plus 1 is 3. So I have two negatives make a positive and two positives, so I have a positive. Between 2 and 5, I can check 4. So 4 minus 2 is 2. 12 minus 2 is 10. 4 minus 5 is negative 1. And 8 plus 1 is 9. Now when I multiply all these together, I get a negative. So lastly, between 5 and infinity, I get a positive, a positive, a positive, and a positive, so I end up with a positive. So now if I go back to the beginning, I'm trying to see when my inequality is greater than or equal to 0. So that's going to happen wherever I have positives. So that is going to happen at, so here is a positive, so that is in this interval. Here is a positive, that is in this interval. And here is a positive, and that is in this interval. Now, I'm going to just have to be really careful. So I'm going to say that x is contained between negative infinity and negative 1/2. If negative 1/2 is an intercept, then it would be equal to 0, and I have to put a square bracket. Since it's a vertical asymptote, it'll never touch it. So in this case, it's actually a round bracket, not a square bracket as I was tempted to draw right there. So only the intercepts would be the square brackets when it's equal to 0. Then it's going to be in union with 2/3 and 2. So I check both 2/3 and 2 are x-intercepts, so it will equal 0. So I can put my square brackets. And then that's going to be in union with 5 and infinity. Remember, infinity always has a round bracket. 5 is not an x-intercept, so it too will have a round bracket. If you're writing it using our other notation, you would just say that x is less than negative 1/2, that x is between 2/3 and 2, and that x is greater than 5. So either of these would be correct. And that is how you solve a rational inequality using an interval table.